Hello, everyone, and welcome to the second part of this lecture where we are going to discuss temporary dewatering techniques. First, what do we mean by temporary dewatering techniques or systems? These systems are designed to remove or reduce groundwater levels temporarily in order to create a stable and dry soil conditions that are suitable for construction activities. These systems are typically employed during the excavation and foundation phases of the projects. Once those phases are finalized, then the systems are deactivated and removed. Why do we use temporary dewatering systems? First of all, those systems are cost effective. They have lower initial and operational costs when we compare them to those of permanent systems. They are flexible and easy to be adjusted and adaptable to when the project needs are changed. They can be easily installed and removed whenever needed. They can be installed and removed quickly. Then they are suitable for projects with tight schedules when the duration of the project is fixed and there's no flexibility to extend the duration of the project, or if there's any emergency situation that needs an immediate intervention. They have a short environmental impact or reduced environmental impact because they are short. They are short in time, I mean, in comparison with the permanent watering systems, and they require minimal maintenance during the operation period. What are the limitations of such systems? First, they have limited duration. That's why they are not suitable for projects that need long-term groundwater management. They have potential instability. That's why they are not able to provide the same level of stability as permanent systems, particularly for large-scale projects. They may suffer from operational interruptions, such as the installation and installation again. They are not suitable for any type of a project. That's why their scope is limited. They are best suitable for construction projects, emergency responses, and short-term interventions. What are the types of dewatering systems that we are going to cover here? First, we have the well points, the sump pumping, the deep wells, the educator systems, and the vacuum well. Let's start with the well points. About their components, they are formed of small diameter wells that are installed in series along the perimeter of the excavation. They are formed of the header pipe that connects the well points together. This head pipe transports the extracted water to a discharge point. Third, we have the vacuum pump that creates a suction to draw groundwater through the well point and into the header pipe. What are the technical advantages of these well points? First, the rapid installation and removal. They are efficient for groundwater control. They are able to lower groundwater in soils of different conditions. They are easy adjustable and can be expanded or reduced according to the project needs. This figure shows this type of dewatering systems. What are the applications? We can apply well point systems for excavations that are used for foundations, basements, and trenches, for utility installation and repair, and also for temporary stabilization of slabs and embankments. Where we are not able to use well points, and well points can be applied for systems with a limited depth, effective for depths between 5 and 6 meters. If you have a deep excavation, they are not applicable. They need continuous power supply, and also they need regular maintenance. The second type is the sump pumping. The sump pump system is formed of a sump pit, which is excavated at the lowest point of the site where the water is needed to be collected, a submersible pump, and a discharge pipe. Some pumping are suitable because they are simple and low cost. They can be easily installed and they are cost effective for short-term dewatering systems. They can be quickly adapted for variable site conditions, and the water can be removed rapidly. They are able to remove large volumes of water, particularly in areas where there is high rainfall or groundwater inflow. This figure shows clearly how the sump pumping system is formed. It is a very simple system. This is the sump at the lowest point of the excavation, and this is the sump pump, and this is the discharge pipe. Where we can apply sump pumping in the excavations for foundations, basement, and the trenches. In projects that needs emergency dewatering, where there is unexpected water inflow, and utility installation and repair. What are the limitations of such systems? First, the effective depth, they are limited to shallow excavations. That's why if you have deeper excavations, you have to keep in mind that your efficiency will decrease, the efficiency of the dewatering system, I mean. Some pumping system may cause soil erosion due to the high flow rates of water. They require regular monitoring and maintenance, and also should be managed to prevent environmental contamination. The fourth type is the deep wells. The deep wells are formed of large diameter wells that are drilled into depth between 10 to 30 meters or more. They are formed of submersible pumps and discharge pipes. They are suitable for projects where there's high capacity of water, of groundwater. They can be effective in a wide range of soil types, whether the soil is permeable or semi-permeable soils. They allow dewatering at a greater depth than surface methods, and they can operate in a continuous manner, ensuring stable and consistent groundwater control throughout the duration of the project. And this is one example or one figure that shows you how the deep well is installed in a heterogeneous soil where there's clay and sand. And this is the original water table, and we have to decrease the water table to a certain point according to our project needs. Where to apply or to use these deep wells? We can use them in large-scale excavations. They are suitable for marine construction where there is large quantities of water in coastal or offshore construction projects near the coast. Underground infrastructure projects are also very useful. But what are the limitations of such systems? First, they have a high initial cost. They depend on continuous power supply to operate, and they need regular maintenance on pumps and piping. Their installation is not easy at all. It is a complex and time-consuming system compared to surface dewatering methods. Educator systems are formed of educator wells that are small diameter wells installed at regular intervals around the excavation site. The typical depth of their usage is up to 20 meters. They are formed of also the educator pumps, where they are high pressure pumps that circulate water through the educator wells to create a vacuum effect, and then drawing the groundwater into certain wells. The discharge piping, which is a system of pipes that carries this extracted water away from the excavation site to a certain discharge point away from our site. What are the technical advantages? First, the educator systems are very effective if your soil has low permeability, such as silts and clays. It can control the groundwater in a uniform manner. That's why we can reduce the risk of differential settlement due to the using of this dewatering system. The small diameter of the ejector walls allows for installation in confined spaces. It's suitable for sites where we have a limited access or space. It can ensure a continuous operation. That's why ensuring steady groundwater control throughout the construction process. And this is the diagram that shows you how the ejector system is installed. This system, the ejector system, can be applied in deep excavations, as I said below, with a low permeability soils. It is useful for underground structures such as tunnels, underground facilities. It is useful for urban construction sites where space constraints and the presence of sensitive structures requires a precise ground control. But you have to keep in mind that this system needs a high power and energy consumption. That's why it leads to high initial setup costs. The maintenance, it's not easy, it's complicated, and it is efficient for moderate depth. Educator systems may be less efficient in very deep excavations compared to deep wells. That means if you have a very deep excavations, it's better to go for deep wells instead of ejector systems. The last type is the vacuum wells that are formed of the vacuum wells, the small diameter wells that are installed around the excavation, the vacuum pumps, and the header piping. They are very efficient in fine grain soils. They can provide precise control over the groundwater levels. That's why they reduce the risk of soil instability or excessive settlement. Um, they can work on in a continuous manner. And this is an example or diagram that shows you how these vacuum wells are installed. Their applications, they are useful in excavations of fine grain soils. They are useful for underground construction projects and for urban development projects. However, what are the advantages or limitations of such systems? First, the energy intensive. They need high energy consumption. That's why they increase the operational costs. They need high maintenance requirements, and they are suitable for limited depth. Also, the power dependency is one of their limitations because they rely on continuous power supply, making it susceptible to disruptions if the power is lost. Thank you so much. This is the end of the part 2 of our lecture. In the third part, I'm going to discuss the all types of permanent dewatering systems. If you find this information useful, you can follow me on LinkedIn, Shaza Sulaiman. You can follow my page at the J Technical Engineering Library on Facebook, Instagram, and YouTube. Thank you so much.